Hello, today we're going to begin by discussing the area of a sector. A sector is a section of a circle that's bounded by a central angle and its intercepted arc. You can think of it as like a slice of pizza. We're trying to find the area of the sector of the circle as a portion of the entire area. And to do that, we use the formula. Area is equal to x as the degree of measure of the arc times pi r squared, where r is the radius, and divided by 360, or the number of degrees in a circle. Let's take a look at an example and see how that works. So we'll do the first one by hand, just to get an idea of the feel of it. And we're going to be using the area is equal to the degrees for the measure of the arc. That's going to be times pi times the radius, which was given to us as 16 feet BC, 16 feet squared, divided by 360. Now there's one important thing to note here. The temptation is to just multiply 15 times pi times 16 and then square it. But remember, order of operations tells us you have to do the exponent before you multiply. So make sure you do 16 squared and then multiply through. Okay, so if you're using the correct order of operations, that should give you about 13,056 pi over 360, which is approximately 113.94 feet square. Remember that we're finding area, which is a square unit. Okay. Now let's use my personally preferred method in Desmos, and we're going to begin by typing in the formula, and I type it in its variable format, which I then apply to the remainder of the problems I need. Next expression line and hit Control V or paste. So I can input this, and then any additional problems I can input it again. So for x, we're finding the measure of it's not 42 though, because we're trying to find the measure of the shaded portion. So what we're trying to find is the larger portion. It's like we're trying to find that entire shaded area. Okay, so x is going to be equal to 360 minus 42. So everything but that little portion. So our arc is actually going to be 360 minus 42, which I can just put in like that, or you can do the subtraction. And our radius is given to us, YZ, as 9. And that brings us to our area of 224.78 inches square. All right. Take a moment and try these examples on your own. My angles are going to be 46 plus 46, or 2 times 46. Okay, so we end up with 92 total arc measure degrees, and a radius they gave us as HG is 7, so radius of 7, which means your area should be equal to 39.34 centimeters square. Okay, for the other problem, we're being given a semicircle, which we automatically know is 180 degrees. And then they also gave us JM. JM, though, would be the diameter. So to get the radius, we would need to divide that in half. Okay, so again, I'm going to control copy, control paste to a new line. My total shaded area is going to include the degrees of 180 plus the 58 degrees, and our radius is going to be 5. That'll leave us with an area equal to 51.92 millimeters square. Now let's take a look at arc length. The length of an arc is the portion of its circumference. Length is equal to the degree of measure of the arc as x times the circumference divided by 360. And remember, the circumference can either be given as 2 pi r or pi d. So let's take a look at our first example. We're given that if nr is 8 feet, we want to find the length of npm. Now look, there's 3 letters there. That should be a clue that nmp, we're using a major arc. So we're trying to find this major arc. Okay? All right, so nr was also given to us as 8. So we have a radius of 8. Okay. Get our arc length is going to be equal to the total number of degrees that we have here, 162, right? And this one would have to be 162. Okay, and then we have the remainder, so we take that and subtract it from 360. Okay, and that means that the remainder would be equal to the other 2 angles together. Okay, so that would give us 198 degrees. And then we would need to calculate the circumference, pi, and a radius of 8, so 16 pi. Okay, so 198 times 16 pi divided by 360, which is going to be approximately 27.65 feet. Why don't you try this one on your own? So for here, we're going to need a new formula, and you can put this into Desmos as just like we did before. Length is going to be formula, and I'm using this as like a template for the rest of them. All right, so in order to find arc length, we need a couple of pieces of information. All right, we're going to need the degree of measure to be. So if we're trying to find the length of CD, that means that EB is 15. So this whole thing together has to be equal to 180. Okay, the semicircle equaling 180 degrees because it's on a straight line. Then we can take 180 and subtract out the 68 degrees given to us, and that should be equal to 112, which would be the measure of the central angle. Okay, so we're going to use x is equal to 112. Then we also need our circumference. We were given a radius of 15, and our circumference is equal to 2 pi r, so 30 pi. And then we just input this in. So x is 112, our circumference is 30 pi, and you should have gotten approximately 29.32 centimeters. Remember, this is a length, so this is not squared, it's just a regular length. ahead and try the next two examples on your own as well. So for the first one, we're trying to find JH, or find the length of KJG. So a major arc has three letters, KJG, all the way around. So everything but that tiny piece right here, which means we've got some additional information that we need to find. The first piece of information we need is this missing measure right here. So if I look, this is a semicircle, divides it in half at 180 degrees. So that means that 100 minus 85 should give us the degree measure of this angle, which should be 95 degrees. Okay, and if this one is 95 degrees, these are vertical angles, this one has to be 95 degrees. Which means now that we can add all of these together, which gives us a total degree measure of 334. And of course, there's other ways that you could have found the remaining measure. Okay. Once you have the degree measure, you also needed to find the circumference, 21 pi, because here they gave us JH as a diameter, so it's just pi d, all right, which would have left you with a length of 5.83 inches. On the second problem, you're trying to find the length of TS, okay, which means that we needed to find some additional angles also, and 128 plus QR would have given us 180. So if we subtract 128 from 180, this gives us 52 degrees here. And if this one's 52 degrees, then this one has to be 52 degrees due to vertical angles. All these added together, subtracted from 360, gives us this arc measure of 97 degrees. Okay, and then you also needed to find your circumference, which would have been 2 times your radius pi, or 9 pi, and or did your calculations, you should have gotten 7.62 millimeters as your length.